Right now, you're traveling through time at exactly 1 second per second. Pretty slow, right? But what if you could skip hundreds or even thousands of years? It sounds like science fiction, but Einstein showed it's actually possible. Here's why. The faster you move, the slower time passes for you. The same happens near something with extreme gravity, like a supermassive black hole. Spend 1 year traveling close to the speed of light or orbiting a black hole, and only 1 year passes for you while centuries pass on Earth. You didn't freeze or teleport. Time itself slowed down. That's called time dilation. But while traveling to the future is possible, traveling to the past is a different story. This is where we meet the grandfather paradox. Imagine going back in time and stopping your grandparents from ever meeting. No grandparents means no parents. No parents means no you who went back to change the past. That's the grandfather paradox, a contradiction that suggests traveling to the past may be impossible. What if I told you our entire universe could be inside a black hole? It sounds like science fiction, but some physicists have seriously explored this idea. We know that everything crossing a black hole's event horizon disappears from our view forever. But what if, instead of ending at a singularity, the inside of a black hole becomes the beginning of a brand new universe? In this theory, every black hole could create its own separate universe with its own space, time, and even its own laws of physics. That would mean our universe might have been born inside a black hole that exists in another, larger universe. And every black hole in our own universe could be creating new universes of their own. Right now, there's no evidence that this idea is true, but it doesn't violate all known physics either, which is why scientists continue to study it. If it's correct, then every black hole isn't just an ending. It could be the beginning of an entirely new universe. Where's the center of the universe? It seems like there has to be one, right? After all, if the universe expanded from the Big Bang, shouldn't everything be moving away from a single point? Surprisingly, that's not how it works. The Big Bang wasn't an explosion into empty space. It was the expansion of space itself, happening everywhere at once. Imagine dots on the surface of an inflating balloon. As the balloon expands, every dot sees every other dot moving away, but there's no center on the surface. The universe works in a similar way. No matter where you are, it looks like you're at the center because everything else is moving away from you. And if you lived in a galaxy billions of light years away, you'd see the exact same thing. That's because galaxies aren't flying away from one central point. The space between them is expanding. This means every observer anywhere in the universe sees the same pattern. So the universe doesn't have a center that you could travel to. In a very real sense, every point is the center, and no point is. There is a place in the universe that is so empty, you could travel for hundreds of millions of light years without finding another galaxy. It's called the Botha's Void, one of the loneliest places ever discovered. This enormous region stretches about 330 million light years across and contains far fewer galaxies than astronomers expected. If the Milky Way were somehow inside it, the night sky would look completely different. Instead of seeing countless distant galaxies scattered across the cosmos, you'd be surrounded by an almost endless darkness. What's even stranger is that scientists still don't know exactly why the Botha's Void exists. According to our current understanding of the universe, regions like this should form. But one this large is still difficult to explain. In a universe containing hundreds of billions of galaxies, it's almost impossible to imagine a place so empty, yet it exists. The fastest thing in the universe isn't light, it's something even stranger. We have been taught that nothing can travel through space faster than light. But there's one thing that isn't limited by that rule: space itself. Right after the Big Bang, the universe went through a brief period called cosmic inflation, when space expanded faster than the speed of light. And even today, the universe is still expanding. In fact, the most distant galaxies are moving away from us faster than light, not because they're breaking the laws of physics, but because the space between us and them is stretching. Imagine drawing two dots on a balloon. As the balloon inflates, the dots move apart, even though they're not moving across the surface themselves. The same thing happens in our universe. Galaxies aren't racing through space faster than light itself, so while nothing can outrun light through space, space has been doing exactly that for nearly 14 billion years. If you were being chased by a black hole, could you escape, or is it already too late? Surprisingly, you can outrun a black hole, but only if you're far enough away. Despite what movies often show, black holes don't suck everything in like giant cosmic vacuum cleaners. From a distance, their gravity behaves just like the gravity of any other object with the same mass. In fact, if our sun were instantly replaced by a black hole with the exact same mass, Earth would continue orbiting almost exactly as it does today. The real danger begins at the event horizon, the point of no return. Once you cross it, escape becomes impossible. Not even light, the fastest thing in the universe, can get back out. No matter how powerful your spaceship is, every path leads deeper into the black hole. So you can outrun a black hole, but if you cross that invisible boundary, the universe has already decided your fate. Right now, you could fall into a black hole and not even realize it. It sounds impossible, but it's true. If the black hole is supermassive, you could cross its event horizon without seeing a wall, feeling a jolt, or noticing anything unusual. Your watch would keep ticking, and from your perspective, everything would seem normal. But to someone watching from far away, you'd appear to slow down more and more until you seemed frozen in time at the edge of the black hole. So, could you survive? Surprisingly, yes, at least for a while, but only if the black hole is enormous. A smaller black hole is far more deadly. Its gravity changes so dramatically over a short distance that the pull on your feet would be much stronger than on your head, stretching you into a thin strand of atoms in a process called spaghettification. Either way, once you cross the event horizon, there's no turning back. Every possible path leads deeper toward the singularity, where the laws of physics as we know them completely break down. Why haven't we found aliens yet? With a universe this enormous, it almost doesn't make sense. This mystery is called the Fermi paradox. There are hundreds of billions of galaxies, each containing hundreds of billions of stars, and many of those stars have planets that could support life. Even if only a tiny fraction developed intelligent civilizations, the universe should already be full of them. Some could be millions of years older than humanity, advanced enough to spread across the entire galaxy. So, where is everybody? Why haven't we found a single confirmed signal, spacecraft, or any evidence of intelligent life? Maybe civilizations always destroy themselves before they become advanced enough to explore space. Maybe intelligent life is incredibly rare. Or maybe they're already out there, and we're simply too primitive to notice. The universe should be full of life, so why does it seem so silent? What if the sun suddenly disappeared? Would Earth instantly freeze? Surprisingly, no. It sounds impossible, but nothing would change at first. We'd still see the sun shining in the sky, and Earth would continue orbiting it for another 8 minutes and 20 seconds. That's because both light and gravity travel at the speed of light, so it takes that long for any change to reach us. But once those 8 minutes and 20 seconds were over, everything would change at once. The sky would suddenly go dark, and Earth would stop orbiting the sun, continuing through space in a straight line instead. Over the next few days, temperatures would begin to fall rapidly. Plants would stop photosynthesizing, food chains would start collapsing, and the surface would become increasingly uninhabitable. Within a year, the average temperature would drop to around minus 73 degrees Celsius, freezing the oceans from the top down. Only organisms deep underground or living near geothermal heat sources might survive, all because the star that makes life on Earth possible simply disappeared.